Hello everyone, I hope you are doing well. So in this video, we're going to discuss the first three problems of Codeforces Round 877, which was rated for Division 2. So I don't know whether it was because of my health that is not very good right now, or the problems were a bit too heavy on observation. I was not able to perform very well. In fact, this was one of my worst contests in the recent times. And anyways, I was able to solve the first three problems, and I didn't have much energy to try the fourth problem. So that is why I decided to make the video. Even though the contest is still running, I'll be posting the video after the contest, obviously. So today's problem were required you to have some critical observations. I was not able to make them very fast, so that is why my rank dropped a lot. But anyways, let us quickly discuss the first three problems. So the first problem is Blackboard List. Now it says that two integers were initially written on a blackboard, and after it n-2 steps were performed. At each step, we have to select any two integers on the board and write the absolute value of their difference on the board. Right. So we have to take the difference and take the absolute value of that particular difference and write it on the board. Now the operations seems very simple, and after you perform n-2 operations, since at each operation one new integer is being added to the board, after n-2 operations, initially there were two particular integers. After n-2 operations, n-2 more integers will be there. So a total of n integers will be finally present on the board, right? So they have given you those n integers that are finally present on the board, and you have to tell what is one of those initial integers, right? This is what your problem essentially says. Now, this particular problem was not very difficult. I'm saying it again. All of these problems were not difficult. It's just that they required some very critical observational skills. So, for example, the first problem says that you take at each steps you are taking the absolute difference, right? So, one thing is for sure, that after each operation, let's say a and b were the initial two integers on the board, any new integer that is being inserted to my array or to my blackboard will be a positive integer, right? Because I'm taking the absolute value. So this thing is for sure that the new integer that will be inserted to my board will be a positive integer, right? That means if there was a negative integer initially, right? If there is a negative, that means in my final list, if there is a that means in my final list, if there is a negative integer, that negative integer has to be one of the starting two integers, right? Because at each step what I'm doing essentially is I'm just adding a new integer, and that is also positive. At each step I'm only adding a positive integer because I'm taking their absolute value. So if there is a negative integer in my list, then that particular integer will be my answer, right? Because it has to be one of the two integers or the two starting integers. Now let's say your array is only consisting of positive integers. So 1, 2, 3, 4, 5, let's say I'm just taking some random values. So these are some positive integers. So now you would always know, let's say there was two integers a and b, right? You are doing a and b minus a and taking it small, right? So if these two integers are positive integers, their value will always be smaller than the largest integer. So let's say I take two positive integers, let's say 8 and 10, right? If I do 8 minus 10 and take its mod, that will be equals to 10 minus 8 and take its mod, right? And both of them would be equals to 2. Now this particular value 2 will always be smaller than the 10, right? Or in a more general case, if there are two positive integers a and b, if I subtract them and take their mod, let's say a was the bigger integer and the result is x. So x is always going to be less than a, right? So I can safely say that if all the integers are positive integers, then the greatest among them will have to be one of the integers that was initially present on the board, right? Because from that integer, all the other integers will be formed, right? Now the resulting integers will always be let's say a and b was there and the result was x. Now if I perform an operation with a and x, it will be smaller than a. If I perform an operation with b and x, it will be smaller than b and x both, right? So this is what I'm saying, that every new integer that you're going to add will always be going to be smaller than the greatest integer. So the final conclusion that we have in this particular question is, if there exists at least one negative integer, that negative integer is going to be my answer. If all the integers are positive integers, then the greatest among them, the last variable or the greatest among them will be my answer, right? So let me just show you the code, how I did it during the contest. So what I essentially did was, I just sorted the input. I just sorted the whole input. I've taken an integer n and I've taken input in the vector v. I've sorted it, and if the first element is less than 0, I just print it. Otherwise, I print the last element, right? If the first element is non-negative, that means all the elements will be positive, right? And if all the elements are positive, I just print the last element. So this would be my solution for the first problem. Now talking about the second problem. So this particular problem, I was not able to think even of a single solution in the beginning. And I solved this problem after solving the third problem. And you can see I also had one wrong summation on this problem. So anyways, this particular problem says that we have been given an integer n, and we have been given a permutation of size n, right? And we have to make exactly one swap such that the number of subarrays which are also a permutation is minimized. So let us just take this particular example for now. I'm going to explain you what do they mean by subarrays which are a permutation. So let's say this whole array 4, 6, 4 and 5 and 6 and 1, 2, 3. This whole array is actually a permutation, right? So this will be counted as 1. Now if I take only 1 and 2, this particular subarray is also a permutation of size 2. So one more added is added to my answer. Now this particular thing is also a permutation, right? So one more is added to my answer. Now I cannot take 1, 2, 3 and 6. I cannot take 1, 2, 3 and 5. I can only take 1, 2, 3, 4, 5, 6. So that is already considered in my first case. Now there are 3 subarrays in this particular permutation which are also a permutation. We have to make exactly one swap. We have to choose 2 indices I and j and make exactly one swap such that after performing that swap, this particular value is minimized. The number of subarrays which are also a permutation is minimized, right? So in any case, obviously, if you have observed, there will be at least one subarray which is a permutation, and that is the whole array itself. Now for the other arrays, we have to minimize this value. Now a very interesting observation, again a question of very high observational skills. Let's say you have 1. All the permutations, be it any permutation of size n, any general number n, will obviously start from 1, right? Now if I want to make a permutation of size n, all the elements between 1 and n should be present, right? Now let's just assume that I take one number from here and replace it with some other value greater than n. So let's say I have taken some value n plus 1 here, right? And I have put it here. So no matter which subarray I take, I will never be able to form my answer, right? For this particular size n, right? And this single observation, with this single observation, you can solve this particular problem, right? Now you can say, what is the smallest value of n that we can have? If I have 1 with me, what is the smallest value that I can have of n? That value is 2. So if 1 and 2 is present here, and I said I want to take a bigger number and replace this particular position with that particular number, right? And if the smallest value is 2, the other values can be 3, 4 and 5 as well, right? So if I fix it for 2, I would also want to fix it for 3, 4, 5 and 6 as well. So I would want to take a number such that it also works for if 3 is present here, if 4 is present here, if 5 is present here. Let me just explain this particular thing to you with an example. Let's say my n value, the total size n is equal to 6 as given in this particular input, right? So I thought that 2 is present here, right? So I want to insert some element here such that this 1 and 2 is separated, right? This is what I discussed. If I have a permutation of size n, I would want to take a bigger number and put it in between 1 and n, so that this particular permutation breaks, because now these n numbers will never have all the n numbers from 1 to n, right? There will be some bigger number greater than n between them, right? So if I had 2, my original idea was to take some other number bigger than 2 and put it in between 1 and 2. So let's say 3 was present here, right? 1, 2 and 3 was written like this, and 3 was present here. Now if I try to put 3 here, so 1, 3 and 2 will be like this. Now the problem with this particular thing is, for value n is equals to 3, all the elements from 1 to 3 are present here, this again form a permutation, and that is definitely not what I want, right? So I would obviously want to take the biggest number that I can put between 1 and 2, right? Why only 2 I am taking? Because I want to destroy the smallest possible permutation by inserting an element between it. I have told you, if a permutation is like this, 1, 2, 3, 4, 5. Now if I take a bigger number, let's say 10, and put it in between like this particular position. Let's say I replace 3 with 10. So this is like this. So this particular subarray of size 5 will never be able to form a permutation. Even though it is just missing a single element, it will never be able to form a permutation, right? So what is the smallest value of n that forms a permutation with 1? And that value of n is 2. So I would want to start destroying my permutation from this 2 size, right? Once I start to destroy from this 2 size, I want to bring some other number greater than 2 in between 1 and 2, right? Now the second thing is the choice of that greater number. I can bring 3, but it would not be optimal because 1, 3 and 2 again can form a permutation. So I would want to bring the greatest number that is possible between 1 and 2. And that in that case will be n that is given to us in the input. So if I bring 1, n and 2 like this in this particular order, or it can also be like 2, n and 1, this would be my best answer, right? Because if I try to form a permutation of size 2, I will have to take 1 and 2 like this, right? And in between n will be present, which will obviously be outside of any permutation range until and unless the size of the permutation is n itself, right? Let's say if I take n minus 1 elements, right, like this. So let's say 1, 2, n and 1 like this, and there were some elements like this. If the size of this whole subarray is n minus 1, this is never going to form a valid permutation, because there will be at least one element which is outside this permutation, and because of which n is inside it, right? So n is replacing some other value which otherwise should have been inside it, only then it would have formed a permutation. But since n is inside it, it is not going to be a permutation. So my whole idea is to bring the 3 values 1, 2 and n, right? I am only considered about these 3 values. I want to bring it in an order like this. Either it can be 1, n and 2, and or it can be like 2, n and 1, right? Now after you have made this particular observation clear cut, there are like some caseworks that you have to do, and that casework is like, for example, n is present at the ending position. So I'm just discussing the different cases that can be there. So n is either here or either here. So let's assume the first case that n is at the first position, right? So in this particular case, if like 2 is like this and 1 is like this, right? So in this particular case, I would want to swap 2 and n so that it becomes 2, n and 1, right? N comes in between. If we consider the last case, if n is at the last and 1 and 2 are like this, in this particular case, I would want to swap these 2 values, so 2 and n, so that it becomes 1, n and 2, right? In the other cases, where n is somewhere in between, let's say n is somewhere here, and let's say 1 is like to the left of n. In this particular case, what I can do is, no matter where 2 is present, I can always try to put 2 in this particular position, right? So that these 3 values are separated. In the other case, if n is somewhere in between and 1 is present here, right, to the right of n, I can try to place 2 at this particular position. No matter, even if it was placed here or it was placed here, I can always try to put 2 in this particular position. Since I always have to perform one operation, so I will always try to put 2 adjacent to n. Like, you just have to maintain this particular thing that 1 and 2 should be separated by n in between, right? This is the only thing that you have to take care of. Other than that, like, this particular observation was difficult. Other than that, it's just some of casework that you can easily do. So let me just show you my submission, how I did it during the contest. So first of all, I have taken the indexes of P1, P2 and Pn. So P1 will be the index of 1, P2 will be the index of 2, and Pn will be the index of variable n. So if Pn is greater than 1 and Pn is less than n, that means the value n is present somewhere between the array. It is not present at the end, right? Now if P1 is present to the left of Pn, I will replace P2 with Pn plus 1. So I'll put P2 to the right of Pn, right? If the element 1 is to the right of n, then I'll try to place P2 to the left of n, right? I'm trying to separate P1 and P2 with the help of n. Now, in case like P1 is the maximum among all of those. If that is not the case in the first part, That means Pn is either present at the 0th position or Pn is either present at the last position. Now, if P1 position is the maximum, that means Pn will be at the 0th position. In this case, I will try to swap P2 and Pn, right? In the similar case, if P1 is present at the border and P1 and P2 would be together, again I will try to swap P2 and Pn, right? In any other case, I will try to swap P1 and Pn. So in this particular case, it is like this. For example, Pn or the variable n was like this, 1 was like this, and 2 was like this, right? So in this case, what I'll try to do is I'll swap P1 and Pn. So 1 will come here, n will come here, and 2 will come here, right? So this is what is happening in the last line. The only observation is that you have to separate 1 and 2 with the help of n, and after it, it's just a bit of casework that you have to figure out. Now coming to the third problem. So this problem again had some interesting observation, and you can easily solve this problem if you are clear about this particular observation. So basically, you have been given two variables n and m, and you have to form a n into m grid, and you have to fill it with numbers from 1 to n into m, right? So each number can obviously be used once, and you have to fill it in such a way such that if I take any element and subtract it with its adjacent variable or the adjacent element, the absolute difference should not be a prime number. So for example, if 8 is present here, I do 8 minus 2, it is coming out to be 6. Now this 6 should not be a prime number. Obviously it is not prime, so this is a valid grid. I can check up, down, left or right. So in all the 4 directions, it should not be a prime number, right? So this is our whole idea. Now let me just discuss some test cases, and with the help of few cases, you will be able to understand it. So let's say the value of n is 4 and the value of m is anything, right? So let's say it is x. So if it is like this, I'm not deciding on the value of m, I just know that the number of rows is equals to 4. I'll tell you what 4 exactly is, but let's just say it is equals to 4. So if it is equals to 4, I guess I've drawn one extra line, so I'll have to erase this, right? So just consider this particular part, 1, 2, 3, 4. I'm writing the number like this. I'll explain you in a while why. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So you see, if you try to write the numbers in this particular way, you will always end up getting even differences between two adjacent elements. So the question is, why does this work, right? So if you check column wise, right? If you go from up to down in a column, you will see that the difference will always be 1 between the adjacent elements. The difference is always going to be 1, which is obviously neither prime nor composite. So it is not prime. I'm considering it to be 1. So it is not prime. This is valid. So each column is individually valid. Now I have to check the rows, right? I have to check the rows. So the difference between adjacent rows, if I take these two rows and these two rows, you will see the difference is always coming out to be 4, right? And that is because there are 4 rows here. So I write 1, 2, 3, 4 and the next number is 5. So the difference is going to be 4, and it is always going to be exactly 4 because the number of rows are 4, right? I write 4 elements here. I write the 5th element here. Difference is 4. So this is as simple as that. Now you will observe if the number of rows is any even number, right? Let's say 6, 1, 2, 3, 4, 5 and 6. Whenever I write 7, 8, 9, 10, the difference between these two will be always going to be 6. So if the difference is always going to be even, that means this is not a prime number. So in this case, the column wise the difference is 1. So we are safe from that side. In the adjacent rows, the difference is always going to be an even number. So we are also safe for that particular side. Now this part is very clear. Now let's say the number of rows were odd. Now this is a big problem. The number of rows were odd. What happens in this particular case is the number of rows are odd. If I try to do the same thing, I write 5 and then I write 6 and 7. The difference between these two values is going to be 5, right? In the previous case, it was always an even number, which is always going to be a composite number since the minimum value of row is 4. So if the minimum value of row was 2, then it could have been a problem because then the difference would have been 2 between two adjacent rows, and that is a prime number. But that is not the case here. The minimum value is 4, and hence it is going to be an even number other than 2, which is always going to be composite number. So even numbers are not a problem here. But if the number of rows are odd, right? If the number of rows are odd, then in that particular case, you have to worry a little bit because this particular odd number can be prime or composite, right? It can be a prime number like 5 and 7, or it can be a composite number like 9 and 15, right? But we don't know what it is. So we try to like, there is one way, like trying to apply the same analogy that we did with even numbers to the columns as well. So let's say if it was like 5 cross 4, so I could have tried to return 1, 2, 3, 4 like this, and 5, 6, 7, 8 like this, right? And go on continuing. But we are not going to go with this approach, because then we'll still have to worry about what happens when the number of columns is odd. Now both number of rows and columns is odd, right? We'll be stuck in that particular case. So instead, we try to form a much better answer, but we'll be using the same idea that we used before, right? We're going to use the similar idea that we used before, but we will try to apply it in a different manner. So let's say the number of rows is odd, 1, 2, 3, 4, 5, and the number of rows is also, number of columns is also odd. So let's say 7. So this is going to be the first row, this is going to be second row, third, fourth, and fifth. So now instead of writing from up to down, let me write left to right. So I write 1, 2, 3, 4, 5, 6, 7, right? If I start the next row from here and I write 8, you will see that the difference is going to be 7, which is a prime number and it is not valid. I would want to make a number here such that the difference is not a prime number. So what should we actually put here if we cannot put 8? You will observe that if you take the non-adjacent row, taking the non-adjacent row is going to be very interesting. Let's see how. So if you took the adjacent row, the difference was 7. If you take the non-adjacent row, any non-adjacent row in this case, if you even take 4, the difference is going to be a multiple of 7, right? What happens when a number becomes a multiple of 7? It becomes a non-prime number. So if I have the first row written like this, now even if I write the contents of the fifth row, so let's say the contents of the fifth row would be 29, 30, 31, 32, 33, 34, and 35. Now you take any two numbers and check the difference between them. So let's say we take this one. So 28 is the difference, which is a non-prime number. So for any of those numbers, if you take the difference, it is going to be a non-prime number, right? So our observation was only that if I am taking the adjacent number, it is going to be a prime number. The difference is going to be prime. If I take the non-adjacent number, the difference is going to be a multiple of 7, which is very helpful for me since it is not going to be a prime number. Now we have figured out that we can take any one of them, but obviously this is not a correct way of solving this problem. If I have 1, 2, 3, 4, and 5, I need to find a systematic way. So what the systematic way would be to take 1, 3, and then take 5. And after taking all of these, I can take 2 and 4, right? I just have to make sure that when I'm taking one particular row, I do not take its adjacent row just after it, because in that particular case, the difference is going to be a prime number if the number of columns are prime, right? So I don't want that. So I'll always be taking the non-adjacent rows. So the best way to take non-adjacent rows, for example, 1, 2, 3, 4, 5, 6, and 7 was there. You can take 1, 3, 5, and 7 first, and then you can take 4, say like 4, 2, 4, and 6, right? So you will see 1, 3, 5, 7, 2, 4, 6. None of these two numbers are adjacent to each other in the actual ordering, right? So this is what you actually have to do. So let me just show you how I implemented it during the contest. You will see that this problem was also not very difficult, but like observation. That's it for like today's all the three problems. So you see I've created a vector of answer n cross m, and I've created a value vector. So I'll show you how it is useful. Now I'm traversing through all the odd numbers which are less than equals to n, and I'm adding it to my value vector. So basically index is starting from 0. So value of 0 will be I, and then value of 1 will be I, value of 2 will be I, and so on, right? So I is all the odd numbers in the initially and all the even numbers then, or you can also take all the even numbers first and all the odd numbers after it. It doesn't matter. Now I have two cases when the value of n is even. So when the value of n is even, I'm just trying to traverse for each column. I'm going through each row, right? So I'm traversing in the top to down fashion. First I move from top to down from the first column, then I move from top to down in the second column, and I just write the value directly there. So it is just like doing like this. So if I have a grid like this, I'm writing 1, 2, 3, 4, and then 5, 6, 7, 8. This is how I'm traversing the for loop here, right? So this is when the value of n is even, and I just directly go to the end. I just don't process this part in between, right? I just go to the end and print my array. Now if the value of n is odd, this part will be executed, and in that particular case, what I'm doing is I'm initializing my item is equals to m into value of I. So value of I, if you remember, is actually storing the order 1, 3, 5 and then 2 and 4, right? So for the first row, I am multiplying m with value. So for the first row, the value of item will be initially 7, right? Let's say there are 7 columns and m is the number of columns, so it will be initially equal to 7. So I'm traversing the row in the reverse order and I'm writing 7, 6, 5. Let me just show you directly so it is easier for you to understand. So if there are 5 rows, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 and 6, 7, right? It is 5 into 7. So initially my value array will be like this: 1, 2, 3, 4, 5 and 2 and 4, like this, right? So I am doing 7 into 1, so 7 will be here, and 6, 5, 4, 3, 2, 1. Then I am doing 7 into 3, 21, 21, 20, 19, 18, 17, 16, 15, right? You could have also written it in front manner, if you write 7, 6, 5, 4, 3, 2, 1, it will always work, but you just have to do the same way, for all the rows. It will not affect the answer, but I showed you how I was thinking about the approach, and that is how I coded it during the contest. And this part is only about implementing. You have got the idea what you need to do. You don't have to take adjacent rows, you just have to avoid adjacent rows. As long as you avoid them, it is going to be a correct answer. And this is how I implemented it during the contest. So I'm just assigning answer of ij is equals to item minus minus. So item will get decremented automatically after it is being assigned to answer of ij. After it, I just print my answer vector, and this was it for today's contest. I hope that you guys were able to understand the solutions. I know that these questions are getting a bit tricky. Don't worry if you're not able to solve them. These are some special questions. Anyways, I hope that you guys were able to understand the solutions in this video. If you guys did, then consider dropping a like on this video, and don't forget to share this video with your friends, and do consider subscribing. I see a lot of people who watch these videos have not subscribed yet. So if you're one of them, then definitely subscribe. Until the next video drops, keep coding, stay safe, bye bye.